Hello class, today we are starting Module 3. The items that you need today is of course your workbook, and also you will need a envelope that I have given to you. It will contain triangles and quadrilaterals, which we will talk about very shortly. Let's get started.
Today's question: how can I simplify expressions with the associative and commutative properties? So please pause the video and write down today's question. Opening exercise. Each envelope contains a number of triangles and a number of quadrilaterals. For this exercise, let T represent the number of triangles and Q represent the number of quadrilaterals. Write an expression using T and Q that represents the total number of sides in your envelope. Explain what the terms means in your expression. The expression will be 3T plus 4Q. Now, what does that mean? Triangles have 3 sides, and quadrilaterals have 4 sides. So the 3 means number of sides, and the Q means triangle. 4 means the number of sides, and 4 means quadrilaterals. B. You and your partner have the same number of triangles and quadrilaterals in your envelope. Write an expression that represents the total number of sides that you and your partner have. And if possible, write more than one expression to represent this total. So the first thing that we can do is and we're just going to say me and my partner have the same amount of triangles and quadrilaterals in our envelope. But I would have 3T plus 4Q. That would be in my envelope. That's the expression that we've already discovered. And I would just write the same thing again, 3T plus 4Q for the other envelope. So now we have, sorry about that. Oop, there we go. So now I have triangle and triangle, quadrilateral and quadrilateral. 4 of those are added together and I can make one expression. Can I simplify this? Yes, I can. I can also simplify this as 2 groups of 3T plus 4Q. And we know that would be said as 2 groups of the same thing. And I can write it one more way. And I can also write that as 6T plus 8Q. So those are 3 different ways that I can write that one expression that would then tell me the number of sides on all of my shapes inside my envelope. Each envelope in the class contains the same number of triangles and quadrilaterals. Write an expression that represents the total number of sides in the room. Just for the sake of today, let's say that there are 20 people in this class. So I can do it just the same way I did the 3 times. I can do 3T plus 4Q plus 3T, and I can do that 20 times just like I did up there. But that's not the practical way. We will do it like we did on this second time here in answer B. We will say 20 groups of 3T plus 4Q. And so that tells me, because I have 20 groups of 3 times my number of triangles and 4 times my number of quadrilaterals. Now let's get on to part D, and this is where you can open your envelope. So you can open your envelope and figure out the number of triangles and quadrilaterals you have inside your envelope. So D, given the use of values of T and Q in your expressions from part A to determine the number of sides that should be found in your envelope. So first it says to use that expression from part A, 3T plus 4Q. And I'm going to open up my envelope, and in my envelope I have 4 triangles and 2 quadrilaterals. So I'm going to replace my T with a 4 because I have 4 triangles, and I'm going to replace my Q with a 2 because I have 2 quadrilaterals. And this will tell me the number of shapes. They are in parentheses, so I'm going to multiply. 3 times 4 is 12, and 4 times 2 is 8. 12 plus 8 is 20. I have 20 sides in my envelope. Pretty simple. Next, let's go on to E. Use the same values for T and Q in your expression from part B to determine the number of sides that should be contained in your envelope and your partner's envelope combined. So let's go back to part B. And remember, we can use any one of those 3 triangles. I like to use the middle one. That one's probably the easiest for me, but you can use either of the 3 expressions. So I'm going to use 2, 3t plus 4q. So I plug in again 4 for my triangles and 2 for my quadrilateral. 2 groups of 12 plus 8. 2 groups of 20, which equals 40. Let me do it one more time. Let me do it with this expression. I'm going to try it with that one just to see if it comes up with 40 again. 6t plus 8q. I'm going to plug in my 4 for triangles. I'm going to plug in my 2 for quadrilaterals. 6 times 4 is 24. 8 times 2 is 16. 40. It also equals 40. Together, we have 40 sides. Question F, use the same values for T and Q in your expression from part C to determine the number of sides that should be contained for all the envelopes combined in the room. So again, we are using 20 students in the classroom and then 3T plus 4Q. So I'm going to use that same number. Let's say that everybody in the classroom has the same thing in their envelope. So 20, 3 times 4 plus 4 times 2. So again, I'm going to do my multiplication. 3 times 4 is 12 plus 8. 20 times 20 equals 400. Let's try it again, just like we did again, using this expression. So instead of doing 3t plus 4q, I'm going to figure out my distribution first. So 3 times 20 is 60. So 60t plus 80q, because 4 times 20 is 80. And then I'm going to plug in my 4 for triangle and my 2 for my quadrilateral. 6 times 40 is 240. 80 times 2 is 160. And add that together, that is 400 sides. We have 400 sides in the classroom. And this brings us to part G. What do you notice about the various expressions in part E and F? So I want you to write something that you know about the different expressions that we use. What is the difference between this expression and this expression? Or what is the expression between this one we used here and this one that we used here? So please write something down in 4G, and that brings us to our first stop and check. When you see this screen, I want you to pause the video and raise your hand. I will come to you. I want to check your work in your book and see if you are doing everything okay. And then I will tell you that you can proceed on to the next part in the book. All right, welcome back. So let's move on. We are now going to do example 1, any order, any grouping with addition. And it tells us to rewrite 5x plus 3x and 5x minus 3x by combining like terms. So rewrite the original expression and expand each term using addition. So first of all, 5x plus 3x. So we know that 5x, we know that 5x can be written 1, 2, 3, 4, 5. That can be written as 5x. And then I'm going to 3x, I'm going to add 3 more, so I can write 1, 2, 3. And now I can go through and count 1, 2, 3, 4, 5, 6, 7, 8. Yeah. And I know that my answer is 8x. I can rewrite 5x minus 3x by doing the same thing. 5x would be 1, 2, 3, 4, 5. And I'm going to take away 3x. So I'm going to take away, that's 3x, I'm going to take them away, and I'm left with 2x. Remember that this number right here, this number above the variable, that can be called a coefficient. You might remember I talked about coefficient with a molecule. A water molecule is usually drawn like that, like a Mickey Mouse figure, which has a oxygen molecule, a hydrogen, and a hydrogen. And we write that we don't write it like that. We just write H2O, 2 hydrogens, 1 oxygen. And if I write a 2 up there, that means I have 2 molecules of H2O. If I write 2x, that means I have 2 x's. That number right there is the coefficient. And that's what we are talking about here today, how we can write it. Pardon for that. Let's go back into the expression. And it did not save it. So let me rewrite that again real quick. 5x plus 3x equals 1, 2, 3, 4, 5, 6, 7, 8 equals 8x. 5x minus 3x equals 1, 2, 3, 4, 5, and I'm going to take out 3x, and that equals 2x. Now it says to find the sum of 2x plus 1 and 5x. So we're going to be doing a few more steps here, but just follow along and you'll understand it. So the first thing that we would write is 2x plus 1 and, which is a plus sign, 5x. That is the original expression. Then let's use the associated property and change things around. 2x plus 1 plus 5x. Let's put my parentheses around this one using the associative property. Sorry, I wrote a little sloppy on that. Now let's use the commutative property. And remember, with the commutative property, I can rearrange my order if they are all the same sign. I'm adding everything together, so I can change the order around with commutative properties. Then I can use associative property again and tell me that I want to do these two first. That would be my associated property again. And now I can combine my like terms. And just like I did before, 2x plus 5x, 2x plus 5x would equal 7x, 7x plus 1. And I will get my answer. So why did we use associative and commutative properties of addition? We were able to reorder, like we did here, and we were able to combine like terms so that I can make it a much shorter problem. I made it 7x plus 1 instead of having all these. I believe 7x plus 1 is much simpler to solve. Now let's do it again. Let's find the sum. Oh, forgot that. Let's go back and check. Let's see if they are the same. Let's see if 2x plus 1 plus 5x and 7x plus 1 are the same. So let's plug in, let's say x equals 3. So let's plug it in for this one. 2, 3, plus 1, plus 5, 3. So where there was an x here and here, I plugged in the 3. So that would equal 6 plus 1 plus 15, which would equal 7 plus 15, which would equal 22. Now let's try it on this one and plug in a 3 also from that one. 7, 3 plus 1. 7 times 3 is 22 plus, oops, my apologies. 7 times 3 is 21 plus 1 equals 22. They are the same. So yes, this expression and this expression are the same. So let's move on to this one. C, find the sum of negative 3a plus 2 and 5a minus 3. So first, let's rewrite the expression. Negative 3a plus 2 and and is a plus sign. 5, no, 5a minus 3. First thing we want to do is we want to get rid of that subtraction sign right here. So remember the rule of subtraction. Negative 3a plus 2 plus 5a plus negative 3. So we used the rule of subtraction and added the opposite. Now let's use any order, any grouping. Let me write that up here in a second. Any order, any grouping. And what I mean by any order, any grouping is exactly what I did here. Doesn't matter any order, doesn't matter any way I group them, it's still going to be the same expression. That's using the associated and the commutative property to our advantage. So what would be the best way to order these and to group these? Because they are all plus signs all the way across, I can use any order, any grouping. So let's group it with my ones with variables and the ones that are not. Negative 3a plus 5a plus 2 plus negative 3. Now this makes it much simpler. Negative 3 plus 5 is negative 2a, and 2 plus negative 3 is negative 1. That's after I combine my like terms. This any order, any grouping, that's using the associated and the commutative properties. And if they're all the same sign, if I have plus signs all the way across, I could rearrange it any way I want. If I wanted to, I could say, I can turn this into 2 plus negative 3 plus 5a plus negative 3a. That is the same one. I could say negative 3 plus 2 plus negative 3a plus 5a. Any order, any grouping is exactly what I'm talking about. You can do it any way you want. And you want to order it and group it in a way that's going to help you simplify it once you combine your like terms. Like I did here, I'm going to combine my 3a and 5a, and I'm going to combine my 2 and my negative 3. Example number 2. Any order, any grouping with multiplication. So just like we know if they're all plus signs, we can use any order, any grouping, it also works with multiplication. So 2x and 3. Find the product of 2x times 3. So I can use my associative properties and I can separate these out, which is actually means 2 times x times 3. That would be using my associated property. And remember that dot means multiplication, just so you don't get my x of my variable and my multiplication mixed up. So that's my associative property separating my 2 and my x. Next, let's use the commutative property. Let's rearrange it. Let's do any order. And let's do 2 times 3 times x. Now that looks a little bit simpler to combine my like terms. Let's do my 2 times my 3 first. And what am I left with? 6x. Which is a much easier way to then multiply. I take my x and I multiply it by 6. Example number 3, I'm going to want you to try A through F by yourself and then raise your hand and do another check. So remember, this is just like the one before that we did before. I want you to simplify it the most that I can. So show me this. If you show me the steps, I did 3 times 2 times x, and then I'm going to do 3 times 2 first times x. 3 times 2 equals 6x. So I want you to try to simplify these terms for B, C, D, E, and F. When you finish all the way to F, again, I want you to raise your hand, let me check on you, and I will let you move on to the next part after it is done. All right. I hope you found the answer on all of those. Let me go back to this. I hope you found the answer of all of them correctly. So let's just move on to the vocabulary real quick. Most of these words are review words, but I do want you to go through and read these words and make sure you know them. We all know what a variable is. We've been talking about it much. It is just a symbol. It can be a letter, it can be a number, it can be many other things. Let's move on to the summary. Remember, we found today the whole part was using that associated and commutative properties to know any order, any grouping. And I'm using any order, any grouping to rearrange things. Because if they are all plus or they are all multiplying, the order does not matter. And the arrangement doesn't matter. So I can rearrange it the way I want it and group it the way I want it to simplify it. Again, let me read the lesson summary for today. Terms that contain exactly the same variable symbol can be combined by addition or subtraction because the variable represents the same number. Any order, any grouping can be used where terms are added or subtracted in order to group together like terms. Changing the orders of the terms in a sum does not affect the value of the expression for given values of the variables. All right, before you begin, I want you to finish the problem set. 1 through 15 is pretty simple. On 1 through 9, you're doing it just like the examples that we did before. You're just combining like terms. Number 1 is pretty simple. 3a plus 5a. They are like terms. They are both connected to the variable. The answer is 8a. For 10 through 15, you need to give me an answer. Tell me what it is. If a equals 3, you are going to rewrite it 3, 6, and I'm going to put in a 3 for that one. And if you want to, you can do any order, any grouping before, or you can do it after to get that answer. I want you to practice, maybe try doing it both ways. 17 and 18 also should be very simple. Try those as well too. And this will bring us to our last stop and check. When you are done with all the problem sets, raise your hand, and we will be done for this today, and I will tell you our next step. And this is the end of lesson 1 of module 3. Thank you.